And we are live, so we'll just give it a few minutes just to allow everyone to come in. I can just see some people coming in now. There we go. Welcome everyone. Thank you for coming. I'll just give it a few minutes just for everyone to move over from the last session. Brilliant. Nice to see everyone. So I'll just do a brief introduction. So welcome to the first session of today. With myself, I've got Professor Gregory Carmichael from the University of Iowa, who will be presenting air quality related science for service activities of the WMO Global Atmosphere Watch Programme. So please, Gregory, please take it away.
Hello, everyone. It's my pleasure to have this opportunity to share with you activities within the World Meteorological Organization's Global Atmospheric Watch Program. This is a program dedicated to using atmospheric composition to, along with meteorological activities, to provide services to society. And certainly atmospheric composition matters. It matters to all sorts of things. Today's session is really focused on air quality, but it also, atmospheric composition impacts weather, climate, and more. Air quality is important because it is most directly linked to human activities in the environment and climate change. We know that health impacts estimates today are there a total of 7 million premature deaths every year due to exposure to air pollution at a very high cost to society. We know that meteorology plays a key role in influencing the pollution levels through, low wind speeds and low ventilation, for example. And so that's why atmospheric composition is so important. And meteorology plays such an important role. And that's why air quality activities within meteorological services are very, very important. And many Met services around the world play an active role, and many more are beginning to play an active role in terms of dealing with atmospheric composition services along with their traditional meteorological services. And so the Global Atmospheric Watch Program, as I mentioned, is a formal program within the World Meteorological Organization. And we provide international leadership in research and capacity development related to atmospheric composition, observations, and analysis. And we do this through a variety of activities. We have a very large infrastructure related to taking atmospheric composition observations. And we do them in a way that has specific and known quality assurance and quality control that allows us to use those data in a variety of integrated products and services. So our work areas of priority are high quality observations, data management, modeling, joint research, and capacity building and outreach. So if we talk just of some of the ways that the program leverages its atmospheric composition observations, we use the observations directly to support conventions such as long-range transport convention in Europe, and also the Montreal Protocol related to stratospheric ozone. We also use them to support climate negotiations. We have the use of the atmospheric composition data to support ecosystem services. We use them to support health, and I'll talk about these. Sand and dust storms. Fires are a big deal today and are growing importance, so we have programs related to smoke, food security, transport security, and weather forecasting. an overarching component of what we do is leading towards this Earth system modeling, which is processes that are needed to improve services related to meteorology, climate, and air quality. And the overarching goal is to improve air quality prediction through the Earth system processes, as indicated by this slide. So let me go into a little more detail about some of these activities that we're doing. A very important component, as I mentioned, in terms of air quality is related to health. Excuse me here. And we have a formal joint program with the World Health Organization. And you can read on this slide that the focus of this is climate and climate services, air pollution, extreme weather, and the targets are small island developing states and urban areas. So what do we do within this program to support health-related activities? You'll hear a lot about that in the session today about the various modeling activities. But we also use the atmospheric composition data to help identify and map air pollution and its sources. We look at health impacts and preventive interventions for occupational exposures for outdoor workers, for both air quality and solar radiation, and also heat events, which also are very, very important from a health disbenefit perspective. We identify national and regional strategies for integrating climate change and increased UV radiation. And we use the forecast and tools that we have, again, to help give advisories for people to avoid exposures to high pollution events. One of our flagship activities is called the GAFIS program. This is the Global Air Quality Forecasting and Analysis System. This is a cross-cutting activity where it's focused on coordination of activities to facilitate seamless provision of atmospheric composition information at various scales. And this is done in collaboration with UNEP, WHO, and IGAC. And we'll hear more about this through various speakers today about some of the actual activities that are enhancing air quality forecasting. But this overarching component is to coordinate and stimulate and to help Met Services and others increase their capacity to provide air quality and related services. A couple examples. The top example is how we use atmospheric composition and models together to increase for the benefit of assessments of health. You know, all the health assessments, this estimate of the 7 million deaths per year due to air pollution come from estimates of exposures to people around the world based on limited observations. And so we use our observations along with models in a way that's called data assimilation, where we optimally put together the atmospheric composition information and the model information to provide more certain estimates of exposure, which gives better estimates of health impacts. Another example, a growing example, is another service that we just recently stood up, and that's a vegetation, fire, and smoke pollution warning system. As we know, fires are growing around the world, and under climate change are expected to even grow more important as a source of air pollutants, and they impact human health over the regions, and we need a better prediction of the smoke if we're going to better predict where the smoke is going in advisories to both firefighters and people living in smoke impacted areas. Just like smoke's an important component around the world, sand and dust storms are also important phenomena around the world. They impact the aviation, transportation systems. They also have another impact to human health. So we have a sand and dust storm warning advisory assessment system that's quite mature. And we have a variety of global and regional models. We have 3 regional nodes that look at sand and dust storms for Asia, the Americas, and the Caribbean areas. a very important component where more and more people are living in urban environments. So we have a strong focus on bringing these air quality and meteorological services to the urban environments. And we have an integrated urban weather, water, and environment program. And the urban hazards and risks are very, very important. And we have active programs in terms of air quality in urban environments, and not only air quality, but also heat island effects. And I think we'll hear later in this session more detailed about activities related to the urban environment. Another important use of atmospheric composition information is not just for human health, but air pollutants also impact vegetation and crops. And exposures to air pollutions can have a very negative impact on food security and reduce the yields from wheat, rice, and corn, for example. And so we need to be able to estimate those damages, those exposures better. And so we have a formal program that's looking at our observations and models to provide estimates of the deposition of pollution, both wet and dry, to vegetation. And you can see some of the things here that are important, but again, so it's not just air quality services are not just related to the human activities, but also to food security. Another important atmospheric composition component that we are very active in is related to greenhouse gases. We have an extensive global measurements of greenhouse gases and have had those measurements for more than 30 years. Those measurements are critical to understanding how the greenhouse gases are increasing, but also those observations are going to be critically important to see how effective our strategies are at reducing greenhouse gas emissions. So we have a formal program that looks at the integrated global greenhouse gas information system and its observation-based tools to support greenhouse gas emissions reductions and to quantify uptakes. And more MET services are, and we encourage more and more meteorological services to become active in measurements and analysis of greenhouse gases. So we're going to hear more and more today about modeling activities, but again, it's very, very important, and our program has an infrastructure for air quality measurements, and more measurements are needed around the world if we're going to provide better and better services. The good news is that the observing system is expanding in terms of our capabilities of looking at atmospheric composition. At one end is this very much this growth of low-cost sensors and what that's doing to enable better understanding and higher spatial resolution of and citizen science related to air quality around us. But it's important to understand exactly what information they can provide to us. And so we have a group that's studying low-cost sensors and their uses, and we're going to hear more about that later in this session. At the other end, we have more and more capacities from space that are measuring atmospheric composition with an incredible resolution, and even geostationary satellites measuring atmospheric composition. So this information stream is, in terms of available to us to inform and to provide services, is really exciting. So finally, we pay a lot of attention to capacity building within the program. We have formal programs to provide capacity building in terms of observations. And we also have capacity building in terms of air quality forecasting. And again, we're going to hear more about this later in the session. So finally, thanks. This is an overview of the Global Atmospheric Watch Program. We're in more than 100 countries. many hundreds of volunteers to this program and working together to increase our capacity to provide air quality related services. Thank you.
Thank you for that, Gregory. Do we have any questions from our audience at all? We have, I think, 5 or 6 minutes until the next session. So if you do have any questions, please put them in the Q&A tab on the right of your screen. We do have an opportunity at the end of the day as well to ask questions. All of our speakers will be gathering together for a plenary to discuss all of the sessions of the day. So I have a question here from Domingos Pedro, who says, "Good afternoon. My name is Sundays Pedro. I'm a weather forecaster living in Angola. I would like to know which tools are more efficient so that we can make a good forecast of the air quality. According to the images you have just shown, I could see that some countries of Africa has bad air quality."
Yes, in terms of providing services related to air quality, from a meteorological perspective, if your service isn't providing those services yet, but certainly one can, the air quality poor conditions typically come under, stagnant conditions, so low wind speeds. So looking at those conditions. But one thing we'll learn later today is that even if you don't have air quality information available to you right now, there are global models of air pollution that are being forecasted every day, and those are publicly available. And so those can be used to begin to integrate in with your weather forecast. And then you'll learn later today that there's initiatives almost in every continent now to provide air quality forecasting support. And Africa is one of the places that we're beginning to work in. And so if you're interested in learning more about growing those services, we'd be happy to discuss with you and to work with you.
Great, thank you for that. I also have another question asking, would the low-cost sensors part be elaborated? And also, they would like to know if it's possible for us to hold a workshop on air quality focusing simply on Africa. I did have a similar question from the Director of Operational Meteorology for Madagascar. And what I will say in terms of the work that Verisian is doing on this platform is that if there is a need or a service that you require in terms of training or specific workshops, do contact us and let us know, and we can definitely see if that's something that we can arrange for you. So yes, Greg, if you could just
yeah, we're very, very interested in building capacity in Africa. We're very interested in Africa, both from as you'll learn more today, the low-cost sensors. Those are very exciting and very useful. How best to use those in terms of providing air quality information from a service perspective, and also from the air quality forecasting. We have training materials. We've done one workshop in Africa already. We're very interested in expanding that interactions. And so if we can find, it sounds like we have some interested partners, and we'd definitely like to follow through with that. And I'm sure we can make that happen.
Excellent. That's definitely sounding like something that could definitely go ahead. If there's no more questions at the moment, I'll wrap up there. Thank you very much, Greg, for that. We'll see everybody in the next session. If you'd like to go to the agenda tab and head there. Again, if you do have any questions that we were unable to answer, we are holding a panel session at the end of the day. Or you can actually message your speakers directly on the event platform and arrange one-to-one meetings with them as well. So we definitely encourage you to use that. But for now, thank you very much, Greg, and thank you to everyone attending.